All right, so this is going to be a video on paragraph proofs. So we've been doing a fair bit of proofs here recently, and so we're going to be talking about a new kind of proof that goes along with two-column proof, which is a paragraph proof. So first off, what is a paragraph proof? So a paragraph proof you can think of as kind of like a more formal proof than a two-column proof. And a two-column proof works just fine. There's nothing wrong with it. But if you want to get into more understanding more complex mathematical topics and why certain math properties are true and whatnot, a two-column proof just doesn't have enough, power in it in order to deduce those higher level things, both in geometry and in fields like calculus and um, real number systems and stuff like that. Real number analysis is what it's called. So things like that, you need a stronger form proof, which is what a paragraph proof comes into. So to kind of tell the difference, think of two-column proofs as sort of an outline. So when you're, let's say you wanted to do a report on a current event or whatever, what you would do is you would, research that current event, and then you would outline what you want to say, or at least what you should do is you outline what you want to say, and then you take that outline and you make it into your piece of work, or your article, your essay, whatever you're going to make it into. Book if you're going to write a book about it. So the two-column proof is kind of like the outline part, right? If somebody read your outline on what you're going to say about a current event, they could probably deduce what you thought, why you thought what you thought, and the reasons behind what you thought just by reading your outline. They don't necessarily need to read the finished work. They can get all that information from your outline. Now, it's not really that formal. It's not really, as quote unquote good as it can be, but it gets the point across. And that's what a two-column proof is. It gets the major points across. It works perfectly fine to prove basic math facts. And it's a good way of getting into, the reasoning behind proofs and how to think about things. A paragraph proof is more like an article or an essay or like a finished written product. It's a little bit more formal. It accomplishes the same goal about proving what you need to prove, but it's a little bit deeper on the reasoning and a little bit more comprehensive in the way it goes about it, right? So we're going to start this by going all the way back to two-column proofs, and we're going to do an algebraic two-column proof. So we're going to start way back when, and then we're going to build our way back up to a paragraph proof. So you guys all know how these go by now. Given and prove, so we always start by writing our given, right? So we have 3x. And again, pardon the handwriting, I'm writing with my mouse as always, so it might get a little bit weird here, but, copying down the given, you guys have seen me do this many times before, so hopefully you're not missing much here if you can't read that well. Right? And then, there's a few ways to solve this. What I would do first is I would subtract 5 from both sides, so we can do here and do a little minus 5, minus 5, and then y, or what do we get out of that? So once we subtract 5 from both sides, we end up with 3x is equal to 6. And why can we do that? Well, by subtraction POE. I'm just going to put sub POE because the less I have to write with this mouse, the better. So subtraction POE. You shouldn't do sub POE because that could also mean substitution. So for subtraction, you should write a little bit enough to get the idea. And then what you do after that is you divide by 3 on both sides. So divide by 3, divide by 3. And we end up getting x is equal to 2 because of the division, POE. And that's QED, right? That's the end of the proof because we've gotten what we want to. We got to the proof statement, right? That's how you know you're done with the proof is when you get to the proof statement. And again, we've done this before, the first type of two-column proofs we've done. And so now we want to take this and make it into a paragraph proof, right? So we're going to take this outline and make it into a article or an essay or a written piece of work. And the way you do that is very simple. You take each line of the two-column proof and you make it into a sentence. You basically imagine yourself talking a person through this proof that didn't understand what you wrote there. They're looking at this proof going, what the heck does this mean? And you talk them through line by line by line. The words you're saying to them are what goes in the paragraph proof. A little bit of cleaning up here and there as needed for the language. So we're going to make your English teachers proud, and we're going to show off all those English, literature, ELA skills you've learned, right? So the first line of the proof, right? The first line of the proof is just, the first line of the proof is just the given. So how do we restate the given? Again, there's a few ways of doing this. Depends on who you are. I'm just going to kind of state like this. So we're going to say that's not what I want to do. There we go. Had to actually get in the box. The problem is to prove that given 3x plus 5 equals 11, the result is x equals 2. Or you can say that the solution is x equals 2. Or you could say we want to prove that given 3x plus 5 equals 11, the result is 2. Again, there's many ways you can phrase this. This is like the topic sentence or the opening sentence of a paragraph, right? There's a few ways you can introduce people into what the problem is, right? So you can have a little bit of fun with that if you want to, if you find writing fun. The second line is subtraction POE, right? That's when we subtracted 5 from both sides, right? And so each line you can think of as like a three-step sentence or a three-part sentence. You want to state what you did in words. You want to state why you can do what you did. That's the reason. And you want to state what the result is. So if you're wondering, how do I write this in sentence form? Think of what those three parts are. What did we do? Why could we do it? And what did we end up with? So what did we do? We subtracted 5 from both sides. Why? Because the subtraction POE says we can. What did we end up with? 3x equals 6. And that's exactly what we're going to write down. So we're going to say we can start by subtracting 5 from both sides of the equation by the subtraction POE, or you can say because of the subtraction POE, or you can say using the subtraction POE. There's a few ways you can, state what the rule is, which results in 3x equals 6. So again, it's three parts. What did we do? We subtracted 5 from both sides. Why could we do it? Because of the subtraction POE. What did we get out of it? We got 3x equals 6. Again, three parts. What you did, why you could do it, and what did you get? And the last one is the division. This is also where we're going to state, that we're done, that we actually achieved the result there. And we're going to do the same thing. What did we do? Well, we can then divide both sides of the equation by 3. You can say, I'll do a little bit of a different transition here, using the division POE, which gives us x equals 2. This satisfies the proof. Or if you want to be fancy, you can say QED, or you can actually type out or write out the Latin words if you know what they are. If you don't, you can ask your Latin teacher. But this is kind of like, how you would just simply put these sentences together, which we'll do here in a second, and that would make your paragraph proof, right? So again, this is a three-part sentence. What did you do? Divided both sides by 3. Why could you do it? Because of the division POE. What did that give you? It gave you x equals 2. It gave us, not yous. And then because it's the last statement here, you want to say that, okay, now I'm done, right? You do want to kind of have that conclusion sentence so people know that, you didn't just, stop halfway through, right? So how does this look actually all complete? Because this still isn't a paragraph proof because, it's just kind of 3 blocks here. We want actually a paragraph. That's why it's called a paragraph proof. So in full, it looks something like this, right? So we have the outline over here, and I'm going to type in the paragraph proof over here in one flowing paragraph so you can kind of see what the finished product is. So, and again, when you do this, you want to clean up the wording a little bit so it flows together. So you might, use different transitions from sentence to sentence and whatnot. Again, show off those English skills that you've learned. We start with, we are asked to prove that given, you can say given the equation if you want to add more words in here, given 3x plus 5 equals 11, that the result is x equals 2. I'm sorry for the odd cutoffs here, but it's just kind of the way it's formatted. We can start by subtracting 5 from both sides of the equation by the subtraction POE. Again, what did we do? Subtract 5 from both sides. Why could we do it? By the subtraction POE. I almost forgot the third part here is what do we end up with, which gives us 3x equals 6. We can then, again, what did we do? Divide both sides by 3. Why can we do that? Using the division POE. And what did it give us? Which gives us x equals 6. This satisfies the proof, right? Satisfies. Oh, must have really misspelled that one. Let me try that again. Satisfies. There we go. So that would be the paragraph proof. And again, it can probably be improved and use better word choices here or there, but for an intro level paragraph proof, this is about what we'd expect, right? Again, as you do more and more of these, you get better at choosing the right words and stuff to use to make it a little bit easier to read. And again, if you need to do a paragraph proof, don't be afraid to start, with a 2-column proof. Do a quick little 2-column proof on the side because you're used to that by now, and then take that 2-column proof, use it as your outline to make your paragraph. It might seem silly outlining just a simple paragraph, but it's math speak, so it's a little bit different than a paragraph you'd write down in English class. So don't be afraid to do an outline first. Eventually, you probably won't need to do it every single time because as you get more and more used to it, you don't necessarily need to have this written down. It's going to be in your head, and you can just translate that directly, right? But for the first time, it doesn't hurt to do a little outline. So that's an algebraic one. Let's do some geometric ones here because we are in geometry class. And again, these are going to probably go much the same way. It's just going to be using more geometric reasoning, which makes it a little bit more wordy, but again, not too bad. So we'll start by doing our 2-column outline and then show the paragraph proof side by side. So we start with our given here. So we're going to say QR. QR is congruent to SR. And again, pardon the bad handwriting, I have to fit it inside these little boxes using this mouse to write. So hopefully this isn't going to be too hard to read, but if it is, again, I'm just copying down the given, right? Given, boom. So let me mark them down the diagram here so it's a little bit easier to see. So we have those two congruent, and we have ST congruent to QT. And so we know how to prove triangles congruent. There's a few ways we can do that, SSS, SAS, ASA, HL, all those things that we've talked about, right? So the easiest one here, in my opinion, would probably be SSS because we have 2 sides already. All we need is one more side, and luckily that side is right here in the middle, which we can call reflexive, right? We know it's reflexive because even in the proof statement it says RT in this triangle, RT in that triangle, both triangles have RT in them, therefore it has to be a reflexive piece that's shared, right? It's fusing both triangles together, it's congruent to itself. It's a free side essentially, right? So we start that, RT congruent to RT, again, pardon the bad handwriting, by reflexive, and with that, we're actually done because now we have triple S, right? We have 1 pair of sides, 2 pair of sides, 3 pair of sides, all 3 sides congruent, all 3 side pairs rather, congruent, therefore the triangles are congruent. So we can just end it with our proof statement. This is going to look really weird, but again, doing the best I can here with this mouse, is congruent to SRT by side, side, side. Again, the order of the letters is important. I am a little bit, me personally as a teacher, I'm a little bit forgiving if you don't put these letters in the right order when you're just starting out because it is a little bit nitpicky, but you should, when you're doing a congruent triangle problem, make sure that the corresponding pieces are in the same spot. It's just, a formality thing, right? If you don't do it, people will talk weird about you behind your back, So how do we translate this into a paragraph form, right? Again, we're using geometric reasoning now, not algebraic one. But the rules still apply. A sentence for each line, 3 parts to each sentence. So we start with our given, introducing the problem. This, again, takes a little bit of time getting used to, but it might go something like this. We are to prove that the 2 triangles, QRT, triangles, QRT and SRT, make sure I get the right letters myself, QRT and SRT are congruent. We are given that QR and SR are congruent and that ST and QT are congruent. We can deduce, and that's a really good word to use in your proofs. If you're not sure what word to use in a paragraph proof, remember this is deductive reasoning. This is reasoning by rules and logic and things we know to be true from previous reasoning. So whenever you're not sure how to start a sentence, just say we can deduce that and then go into what your reasoning for that sentence is. So we can deduce that RT is congruent to RT. That's our statement. What did we do? We said that this is congruent to itself. Why do we know that's true? By the reflexive property. Right? If you want to be a little bit more detailed, or if you're not sure, again, what the name of the proof is, you can say because we know that something is congruent to itself. A thing is always congruent to itself. If you're not sure what it's called, remember it's called the reflexive property, you can state what the reflexive property says as well, right? So if I didn't know it was called the reflexive property, I would say we can deduce that RT is congruent to RT because a thing is always congruent to itself. You know? Which is a little bit good thing for a paragraph proof. In a two-column proof, it's kind of hard to do if you forget what the name is of the reasoning. It's kind of awkward to fit that in here. In a paragraph proof, it's not really that awkward. It's just a little bit more wordy. And then after that, what's our last statement? Our last statement is the proof statement. So how do we know they're congruent? And so we can say here, we can kind of do this all in one go here, right? We can say, thus we can conclude. Also a really good word to end your paragraph proof with because you are concluding something from a proof. That triangles QRT and SRT are congruent because of the SSS theorem, right? Again, don't be afraid to use the words theorem and postulate when you're doing your paragraph proof. They're a good way to kind of, again, end the proof there. Or, during the proof as well if you're not sure what to call it or how to use your sentence structure and whatnot. So that would be an example about how to translate this two-column proof into a paragraph proof. And again, there's probably improvements that could be made to this paragraph proof I just wrote here, but this would be what I expect as like, a beginner level paragraph proof, right? It's a little bit clunky in some places that you can make the sentences flow better. Again, you can use those English skills you've built up there to kind of make this a little bit easier to read, but this gets the point across and it's a good way to, get practicing, right? Let's try two more here, so yeah, just two more. So this one here, a little bit more steps. And some of these you might remember because we've done some of these before. So hopefully these are looking a little bit familiar. To save time on this video, I'm just going to do this quick little cheat here. Again, you should not do this unless it's doing your own notes there because your notes are your own. But when you're doing an actual thing for like an assessment or whatever, make sure that you write these down. So this by given. Okay? Again, I'm just doing this to save time on the video, folks. And again, let's mark it down here. So QS bisects PQR. So we can't really mark that down just yet. PSQ is congruent to RSQ. That we can mark down. PSQ congruent to RSQ. Two little arcs there. I'm actually going to number these angles because, like I said, this is usually easier for me to write. So I'm going to number this as angle 1, 2, 3, and 4. Again, it's kind of hard to see, but 1, 2, 3, 4, right? 2 is up top, 3 is on bottom. Prove the triangles are congruent. Well, we have a bisector of an angle here, right? So we're probably going to be using definition of angle bisector. No, that's usually what happens when we bisect an angle. So here we'd say def of angle bisector. I keep hitting that marker there. Bisector. The key on my mouse that pops up like that, random 4 there. And now, what does a bisector do? Well, a bisector usually gives us two equal things, one on each side of the bisector, whether it's a segment bisector or an angle bisector. So where is QS? So QS is this middle line here. It's bisecting PQR, which is this far angle right here. So if it's bisecting that far angle, this entire angle here, PQR, that means that the top half of the angle and the bottom half of the angle need to be congruent because that's what a bisector does. So we can conclude that angle 2 is congruent to angle 3. Right? By definition of bisector, it gets cutting that far angle in half to two equal parts. And so now we have these two angles congruent, double arcs for them. So we have two angles, angle pair congruent. We need a side pair. And luckily, once again, we have a reflexive piece, QS and QS. So we can say that QS is congruent to QS by reflexive. And these are bars over them. So, making sure my mic is still working, hopefully. Now that we have them as reflexive, we can go ahead and finish our proof because now that we have two angle pairs and a side pair between them, or a side congruency, we can finish the proof by saying that angle, or triangle rather, PQS is congruent to triangle RQS by, again, angle, side, angle. The side is between the two angles, so it's ASA in this case. Right? So 4-step proof, right? Give or take. So how do we translate this into paragraph form, right? Hopefully this doesn't run off the page, or at least hopefully not much. So once again, we start with our given and stating the problem here, right? So we want to prove triangles PQS and RQS are congruent. We are told, or we are given, that QS bisects PQR and that angle PSQ is congruent to angle RSQ. And again, if you don't want to use if you don't want to type out the word angle, whatnot, you can use the angle symbol. So you can use this symbology in your proof as well. It makes the writing a little bit less for those that get writing fatigue. I should probably put angle here if I'm not going to use the symbol. So I could do something like this, right? So that QS bisects angle PQR instead of writing the word angle. And again, I could write the congruency symbol instead of typing out the word congruent. Just typing it out, I don't have that symbol on my keyboard, so that's a little bit easier for me just to type it out. But you can use the symbolic abbreviations as long as you're using the proper symbology when you're doing your paragraph proof, right? So we can deduce, that favorite word there, deduce, that angle 2 is congruent to angle 3. And again, if you're going to use numbers for your angles, make sure you number them on the diagram so I know and the person knows what angles you're talking about. Because of the definition of angle bisector. Again, if you want to be a little bit more detailed here, you can say because given an angle bisector, it will split the angle into two equal halves. So if you don't remember what the phrase is the angle bisector definition, you can say because an angle bisector cuts an angle into equal halves. So therefore, angle 2 and angle 3 would be congruent. Another thing could be something like this. If I want to rephrase a sentence, I can say because an angle bisector splits an angle into two equal angles, we can deduce that angle 2 is congruent to angle 3. That'd be another way of saying the same thing. It's probably a little bit more formal, a little bit more professional to write like that, but again, gets the same point across. We can also know, again, deduce, know, those are good words to use to transition from statement to statement, that QS is congruent to itself by the reflexive property. Let me see if I can't make this font a little bit smaller so I can fit it all in here. There we go. So we have the reflexive property. Now, again, still three parts. What do we know? QS is congruent to itself. How do we know it? The reflexive property. We don't really have a what the result is like we did in algebraic proof because there really is no result. We're just stating a fact here. The result is going to be at the very end with angle side angle. So speaking of which, thus we can conclude that triangles PQS and RQS are congruent because of the ASA theorem. And then you can just stop there, really. If you want to say this satisfies the proof, you can. Again, QED, whatever the Latin words are, if you want to be extra fancy, that all stuff is good. But this would be a perfectly good, two-column proof, or sorry, a paragraph proof rather. Again, it takes every statement in here, makes it into a nice English sentence that states what's going on. And you can see why this would be more useful in complex mathematical properties because complex mathematical proofs don't really have nice step-by-step rules to them. Sometimes the way to get from one step to the other is a little bit more advanced and requires a little bit more thinking and explanation, which is something you can't really do in a two-column proof, you do in a paragraph proof. Otherwise, each of these little things here, instead of saying definition of bisector, you have an entire paragraph there just explaining what this one step is. Well, if you're going to write an entire paragraph there anyway, might as well do it in a paragraph proof, right? So again, in upper level math, you don't have these like nifty little, topic abbreviations for things. You have to actually write down what the heck you're thinking of, right? Let's try one more here, right, to wrap it up. Okay. Hopefully this won't crash on me because it's the second time I'm making this video, so hopefully it doesn't crash. Given that JK, again, I'm going to save some time here and save some time for you guys as well. So we write that in our given spot, and we say given. Again, write it out when you're doing your tests, quizzes, and RPSs. For your notes, your notes is your notes. Given. Prove that these two triangles are congruent, right? JML congruent to MJK. Well, we know we have parallel lines, which means we know that we have stuff like alternate interior angles, consecutive interior angles, that sort of thing, right? And so remember, alternate interior angles look like a Z pattern, and we definitely see some Z's here, right? We have this Z right here, and this little Z right here. Technically, I guess you'd call this an N, which is just a sideways Z. But remember, alternate interior angles follow that zigzag pattern, right? So we have this zigzag here. Again, if I number my angles here as angle 1, 2, 3, 4, 5, and 6. 2s are the hardest with my mouse here for some reason. Well, 6 is not that easy either. So I can probably say, not probably, I know that angle 2 and 4 are going to be congruent because they make that zigzag angle, right? They're alternate interior, as well as angles 5 and 3. Those are also going to be alternate interior. So let me write that down here. I can say that angle 2 congruent to angle 3, and angle 5 congruent, oops, sorry, not 3, angle 2 congruent to angle 4, and angle 5 is congruent to angle 3. Got my angles mixed up there. And this is by alternate, that's an A there, by the way, alternate interior angles, ALTINT, alternate interior angles. And again, if we want to prove that JML is congruent to MJK, it's a little bit hidden here, but JM, MJ, that's that reflexive line in the middle there, right? This guy right here. JM right there is in both triangles. So it's congruent to itself. JM congruent to JM by reflexive. Reflexive. And again, to save some time, well, I'll just write out, I guess. Then we can say that the two triangles JML, ML is congruent to MJK. Why? Well, we have, again, a side between two angle pairs that are congruent. And so this would be by angle, side, angle again. Whoops, that was really bad. Let me try that one more time. Angle, side, angle. Right? So we have our outline. Let's make it into a two-column proof. Right? Last one here. Let's rally for it. So once again, we state what the problem is and what we're given. So we are to prove that triangles JML and MJK are congruent. We are given that JK is parallel to LM and JL is parallel to KM. Right? This is just taking our given line, making it into a sentence or two. We can deduce that angle 2 and angle 4 are congruent. We're going to get really fancy here, as are angle 5 and angle 3. Oh, we're doing them both together here, right? Really fancy. I'm going to make a new sentence for our second. Remember, it's a three-part sentence. This is getting a little bit long, so I'm going to cut the sentence off, make a new sentence saying why we know that's true. This is because of the alternate. I'll put a little bit of abbreviation here. We'll say alternate interior angle theorem. Again, what do we know? Angle 2 and 4 and 5 and 3 are congruent. Why do we know that? Because of the alternate interior angle theorem. You can also say because they make alternate interior angles, and we know that those are congruent by the alternate interior angle theorem. Again, you can kind of say what the theorem says itself if you don't remember what the overall name for the theorem is. We also know that, this is the one we've done before, Jm is congruent to itself because of the reflexive property. Again, what do we know? Why do we know it? Thus, we conclude that triangles JML and MJK are congruent because of the angle side angle theorem. Again, this might seem like a longer version of two-column proof, and it sometimes is, but this is mainly to get you guys ready to tackle more complex mathematical topics both in and outside of geometry, because this is how they're going to be explained to you, right? If you want to learn about a new topic in calculus or upper level math, they can't really prove that to you. They can't really tell you what the topic is in a two-column proof way because it's too complex. They have to tell it to you like they would tell you anything, like you would learn about, a new vocabulary or about the meaning behind a certain piece of literature or about what happened in history. That's not necessarily something that can fit in a two-column proof way. You have to just type it out in a paragraph or write it out like you would most things. And so that's where the paragraph proof comes in. So that kind of wraps it for this lesson. And again, one reason both for two-column proof and paragraph proof, one of the reasons why we tackle proofs in math, especially in geometry, is because they are not just a way for you learning the mathematics, which is important, but they're also there to help you improve at organizing and arguing your ideas, right? If you have an idea, even if it's not math related at all, if you just have an idea about philosophy or just a idea that you live by, right, or a political idea or anything like that, if you want to communicate that, this type of proof, doing these types of things, helps you format your ideas so you can effectively communicate and debate and argue and back up your ideas between you and your people around you, the society that you live in and whatnot. So it's actually kind of a skill that far outstrips just math. In fact, as just a little bit of a side story here to wrap this up, as a teacher, one of the teachers I used to work with said that the math department always was the one that got everything they asked for when they asked administration for something, because they were the department that knew how to argue their points the best and knew how to present their why they needed certain things. If they wanted a certain item or wanted a certain to use funds to buy a certain thing, they were the department that knew how to organize their thoughts and communicate their thoughts, because this was part of their curriculum. This was part of what they do on a daily basis, is formatting their ideas to communicate from one person to another. So yes, this is a little bit more Englishy than math, but it's again, a marriage of the two topics here. So that wraps up this video. Hopefully you found it instructive. If nothing else, let me know if you have any questions. Have a good day or night, depending on where you're at.